Device usage. In this nugget, we spend some more time on form factor, first examining the monitor as an output device and the basic differentiations between the types of monitors. Then we look at various device form factors. For instance, what is the difference between a desktop PC, a workstation PC, and a server? As an IT sales representative, you're going to need to have this vocabulary under your belt, so to speak, in order to be credible and effective in your jobs. Let's get going. As we know, a monitor is the standard output device with computer systems, and buying decisions for monitors are generally going to fall across the following lines. Number one, the actual form factor, which we'll talk about in just a second. Number two, how good of a picture does the monitor have? Now, that's kind of the layperson's way to describe it, how clear and bright the image is. But as IT sales professionals, we need to get under the hood a little bit and talk just for a moment about picture elements or pixels. When we're looking at monitor specifications, we're going to need to look at the maximum resolution that's supported by that monitor. A picture element is a tiny little dot that represents the smallest addressable area of video on a monitor. And resolution is typically given in the number of pixels horizontally across the screen and then the number of pixels vertically down the screen. So a baseline resolution, and this is a pretty low resolution nowadays, would be 1024 picture elements or pixels across by 768 vertically. Now, standard resolution assumes an aspect ratio of 4:3. An aspect ratio just refers to the relationship between width and height of the viewable picture. Nowadays, though, with widescreen video being so popular, we have the 16:9 ratio, and this brings with it a whole host of alternate higher resolutions. Now let's tie in some things we've learned from earlier nuggets. Yes, we have to make sure the monitor we're suggesting for our customer supports the color depth and resolution that they need for their work. But where does the power for those graphics come from? The answer to that question, of course, is the video adapter card inside the computer. In order to give your customer the best bang for their buck and to meet their needs with requirements for video, we have to ensure that the computer's motherboard has either integrated in its circuitry or on an expansion bus an appropriately powered video card. The video adapter card works hand in hand with the monitor to give you that pretty output. Another gotcha is that monitor sizes, 17-inch, 19-inch, 20-inch, 21, all the way up to 30 and beyond inches, is normally given diagonally from bezel edge to bezel edge. It's one of those marketing terms. Of course, folks who make these monitors want to give you the highest number possible. So you might have a 19-inch CRT monitor here, but that's 19 from bezel edge to bezel edge. You'll also see a smaller number in the specifications that give you the actual viewable size of the monitor. It's kind of a cheat as far as I'm personally concerned. Now, CRT or cathode ray tube monitors are hopefully going the way of the Dodo now in 2010, 2011. Number one, they're huge. As you see, they're as wide as they are deep. Number two, they're extremely heavy. Number three, because of their size and weight, they tend to take up a lot of room on a user's desk, and the more physical real estate we can give our customers, the better. That's a nod toward the LCD monitor for sure. And also there's the disadvantage that CRTs are so energy inefficient, and unless an IT department has controls in place to turn off the monitor after a period of time, or if the corporate culture is such that they're into green IT and into renewable resources, they will physically shut off the monitor when they finish their workdays. Unless you're doing that, the company is likely to spend a lot of extra money maintaining power to these beasts. CRT monitors have a huge power draw to them. Now, since we've jumped down to form factors, let's continue. We just talked about CRTs. The current generation of computer monitors uses liquid crystal display technology. Now, there's some variants there that we don't need to go into. Bottom line is LCD monitors are going to give us a flat screen appearance, which is nice for many reasons. If you've worked with a CRT monitor, the glass front is convex. so you wind up with glare points, whereas a flat screen, by virtue of it being flat, number one, and coatings that are placed on the screen, number two, you've got a much better viewing angle of that screen. Let's pop out to Google Images and take a look at some pictures. I've just done a Google search for computer monitor, and of course we get quite a few returns on that. This is an interesting picture here that shows us the front and side views of a typical LCD display. Now I want you to see a few things here. Note that your size, the manufacturer's stated monitor size, is going to be more realistic because the bezel on LCD monitors, and by bezel I mean this protective outer covering, tends to be a lot smaller than it is with CRT monitors, so you get more screen real estate. You'll also see with LCDs that you have more of the 16:9 widescreen aspect ratio as opposed to the old school 4:3 that looks kind of like a box. Number three, I don't know, I'm kind of enumerating on the fly here. Maybe I should just use the verbal equivalent of bullet points. You note that in the side view here, that this LCD display takes up a tremendously small amount of space on the person's desk. Look at how thin the monitor is, number one. You also see this articulation arm here. You can often swivel these guys horizontally to turn them in one direction and another while keeping the base fixed forward. I've also worked with LCD displays that swivel up 90 degrees. In other words, you're seeing this in a landscape view now. You can swivel the monitor 90 degrees to go in kind of a portrait mode. This can be useful for copy editors and folks that work with a lot of text. For all these reasons, and energy consumption, better energy consumption being yet another one, LCD monitors are a really great thing. I mean, on my desk, as of this recording, as I'm recording this for you right now, I have two, I don't remember if they're 20 or 21 inch LCDs, and they take up not too much more room than my old big old CRT that I had. Now this segues into our next point. Let me bring up this image of an old dinosaur CRT. You'll note that monitors tend to have very few controls on them. Typically you'll have a power button and then you'll have a series of menu buttons. This brings us back to an exam objective dealing with auto adjust. These menu buttons are useful for doing things like force changing the aspect ratio of the monitor, adjusting the orientation of the picture. In other words, you can shift the viewable image up or down in the viewing frame. You can correct some warping that might be there. You might have, for whatever reason, kind of a trapezoidal effect, or you might have concave or convex pinching or stretching of the image. You can control those things with the hard buttons that are on the front of most monitors. The exam objective points us to a really nice feature that's on most contemporary monitors, where you can just hit the button once to do an auto adjust, where the internal circuitry of the LCD will adjust the monitor's settings for optimum use. And in my experience, most of these monitors do a pretty decent job of fixing themselves with just a single stroke of the auto adjust. To come back down to form factors, we haven't yet talked about the projector. In my experience, most of the time these LCD, DLP, there's a whole lot of different technologies under the hood with these, are typically reserved for corporate classrooms or conference rooms. Now in the personal front, I know people who have set up projectors for use with their home entertainment center that gives you a true indoor theater experience. Projectors have come a long way now. They're capable of doing high definition signal, especially when they're mounted top down, that is to say from the ceiling. You don't have to worry about somebody passing in front of the image. You can generate huge images. Again, great for conference rooms or technical training classrooms. You can project a computer screen or a television output on a really large format destination. If there's a downside to projectors, it's they're pretty darn delicate. The bulbs tend to cost a lot of money. I mean, sometimes the replacement bulbs cost half as much as the unit itself. We're talking literally hundreds of dollars for just the replacement bulb. So when you're purchasing a projector, you want to look at things like you would on the monitor. The size of the image, the resolution and color depth that are supported, but you also want to look at what are called field replaceable units, or FRUs, also called consumables. You want to look at the replacement cost for things like the bulb and make sure that it's cost effective. Make sure that the average lifespan of a bulb on one of these is good. Remember, they're also delicate in as much as being turned on, turned off hard. You want to make sure to educate your customers or your users when they're considering implementing one of these projectors, because they require quite a bit more care and feeding than does a typical LCD or CRT display. Now we'll undertake a consideration of the various device form factors in use today, starting with a discussion of the desktop PC. Now some of this we've already discussed. We've talked a little bit about the history of the term PC, personal computer, but when we talk about desktop PCs with respect to information technology, we're talking about a general purpose fully functional computer, not a computer that's cut down in size or optimized for mobile use like a netbook or a notebook computer, not having the purpose of sharing resources with several other users on the network. That would be the role of the server. This is just Joe user or Jane user's desktop PC that they're issued by their company's IT department in their cubicle or office. Now on the consumer front, desktop PC would be called just your home computer, the computer that's under your desk that's used when you're home, I guess. No other way to put it than that. As far as differentiation with desktop PCs, modularity and expandability are key. As we've talked about earlier when we cracked open the virtual case and looked at the motherboard, we talked about the expandability of things like RAM memory, being able to pop a CPU out of its socket and put in a faster model. Of course, the expansion bus with all of those various slots that allow you to put special purpose adapter cards, and then as newer, faster versions of those cards come out, replace them yet again with an eye toward keeping your computer as current as possible for as long as possible. Okay? Now we're going to see that this modularity and expandability issue with desktop PCs is a huge trade-off when we start talking about laptop computers and especially netbooks. The two basic form factors for desktop PCs are the tower case, which we can visualize like this, kind of a vertical arrangement. It's very smart design. Let me kind of put it in 3 dimensions here, because as previously discussed, the front gives us our drive bays, our optical drive bays. Nowadays, most desktop PCs will have multimedia flash card reader slots, USB slots conveniently located on the front. Inside the case, the MOBO or motherboard mounted or stood off one side of the case, expansion cards and ports and all this facing the back. It's a really smart way to put a computer together. I also mentioned the other alternate form of the desktop case. This is one that's intended for the desktop itself. You can oftentimes put the monitor directly on top of the case there to decrease the profile on the user's desk. However, I've found in my industry experience that folks tend to vastly prefer the tower case because we can keep that case under the desk instead of having the actual box on the person's desk, which no matter how you slice it, is going to take up quite a bit of room. The other chief form factor with desktop PCs is the all-in-one or integrated unit. This style has been pioneered by Apple. At this point, let's head on out to Google search again, and I want to show you here. You can see kind of the evolution of the iMac. The iMac is Apple's flagship or standby desktop computer model. You see that originally the iMac had these great big honkin' CRT displays. Gradually the form factor evolved. You see this iMac where the LCD flat panel is kind of suspended and the rest of the computer is down in this really pretty looking half globe. You have to hand it to Apple. Their design is just stunning, actually. The current generation iMac, I do have one of these on my desktop right now. Again, it's a work of art, it's a thing of beauty, but it actually runs really, really well. This is again the all-in-one integrated design where literally this is it to the computer. The main unit of the computer is a little wider than a traditional LCD monitor as a whole. The back panel of this guy has all of your ports, your USB ports, your FireWire ports, your Ethernet port, and so on. Obviously, the graphics are integrated into the case. You see this slot here on the side. This is for optical media, CDs, DVDs, and potentially Blu-ray discs. I have a more recent version of the iMac than what you see here. I actually have a couple flash memory slots down below where I could, say, pull a card out of my digital camera and pop it directly into my iMac. Doing a Google image search for computer case gives us all sorts of wacky things here. Check this out. I mean, enthusiasts, really can take the computer thing not too far, because I think this is pretty interesting, and especially as a motorcyclist, I'm attracted to this particular case design. But you just see some of the creativity that goes into a desktop tower case. Now, some folks go for the really pretty cool stuff like that. Other folks are more utilitarian. This is a utilitarian case that might have high security on it. Maybe there's locks. I mentioned in the earlier nugget how easy it is in general to open up these tower cases, just a latch or a thumb screw. On the other hand, for higher security environments, you might decide to go with a PC that has a case that's much more secured, you see. Yet another enthusiast mechanism with these cases is to design for maximum airflow. I mean, I'm looking at some pretty crazy cases right here. If I add cooling to my search, I can see, again, you could spend some time here just on Google Images looking at some of these wacky images. This is a case that looks like it's comprised entirely of fans. Isn't that unbelievable? So you see that the story runs from soup to nuts with this kind of stuff. Next, let's differentiate the desktop PC to the workstation. Now, a workstation is also considered a desktop PC, so really a workstation would just be a variant of a desktop PC. Workstations are higher-end desktop PCs. By higher-end, we mean that workstations have more powerful components. They have upgraded memory, CPU, disk, network, graphics. Because workstations are generally issued to workers, or home users will buy a workstation to fit a dedicated function. Maybe you do, or an employee does, heavy audio-video editing. Maybe the individual is a graphic artist. Perhaps they do computer-aided design, drafting. Maybe the individual is an IT systems administrator who needs that extra horsepower because he or she is constantly making connections to other machines, etc. Another workstation scenario in business is that of the programmer or software developer. As far as a home user's goal in purchasing a workstation, it could be any of these, of course, but also gaming is certainly an issue where we would consider one of those desktop PCs a workstation because it fulfills both of our requirements: higher than normal amounts of these hardware components and also dedicated function. Many folks who are new or newer to information technology get hung up on exactly what a server computer is. First of all, a server is a role. Similarly to how a workstation is really a specialized role of a desktop PC, a server is defined as a high-end, powerful computer that provides services to network users. Now, what are some of these network services that a server offers? These deal with server roles like file and print services. In other words, you may have file servers that centrally store and protect documents that are created by the employees in an organization. You may also provide file shares such that work groups can collaborate on material and, again, put that material in a central location. This provides ease of access for the users because they all know where to go to retrieve those resources, and it also gives the IT department peace of mind because the IT staff can back up the file server's system each night to protect against accidental or malicious data loss. If that happens, they can simply restore from the most previous backup. When users are keeping data on their individual computers, that's an IT administration nightmare, because if Joe user or Jane user accidentally deletes a file on their file system, it's probably going to be a lot more difficult to help that person. Whereas if their files are centrally stored on a server, it can be quite easy actually. Other server roles that servers provide are things like application services. You may have an accounting department where instead of having a locally installed accounting application on everybody's computer, they all use their web browser to connect to a central application that's stored on a server. Again, the idea here is ease of access for the end user and ease of administration for your IT staff. Let me come back to the print role because that's yet another really great server role. Your organization may have one of those great big multifunction workgroup printers on every floor. Are you going to want to go to each one of those devices on a regular basis to make tweaks and twiddles, resolve security issues, and other software kinds of changes? Or would you like to sit at your desk in your office and be able to remotely administer those printers. Well, strictly speaking, you don't need a physical server computer to do that, but having what's called a print server makes security and administration of print devices a lot easier to manage, and the end user just can go retrieve their documents as usual. Now, servers provide lots of different services. We'll just look at one more very briefly, and that is the web server. Oftentimes, inside a corporate network, an application server and a web server are the same thing, because as I told you over here when I gave you my example of a centralized line of business accounting application, many business applications now are running as web services instead of as locally installed applications. Now, as far as form factors for servers go, you can actually co-opt a workstation desktop PC and make it a server. Really, what differentiates a server from a workstation computer is the operating system that's running on that hardware. Microsoft, for instance, makes desktop versions of their operating systems, which I'm sure you're familiar with. Windows 7 most recently, Windows Vista, Windows XP, etc. However, there's also a server class line of OS from Microsoft. The most recent version is Windows Server 2008. In Apple land, Apple has Mac OS X Server, and pretty much any distribution of Linux Unix can be used as a server. So in that case, Linux Unix is a little bit different from the Windows or Mac worlds. Now, how does, say, Windows Server 2008 differ from Windows 7? At first glance, not all that much. A server operating system is going to have a graphical user interface, although that's not required, but you're not going to need the nifty graphical arrow effects, for instance, that you get with Windows 7. Windows Server 2008 looks pretty darn humdrum, although it has the basic My Computer icon, the Start menu, the taskbar, all of those familiar elements. Where Windows Server 2008 and Mac OS X Server differentiate themselves from desktop operating systems is that they have a whole lot of built-in software that's devoted to these aforementioned server roles: file and print services, application services, web services, and so on. Also, we have the idea of the centralized user account, where we can define our network users in one spot on the server, and then the employee can log on to any computer in the enterprise with that single account instead of having to keep track of multiple account names and multiple passwords. Continuing our form factor discussion, although as I said you can co-opt a workstation PC to make it a server, most IT departments worth their salt will purchase a dedicated server appliance from an original equipment manufacturer. I have a lot of experience myself with the Dell PowerEdge line of business servers, and you're seeing two of them right here. They all tend to look about the same. They have a pretty standardized appearance. At first blush, you're probably thinking to yourself, what is this? What am I looking at? Well, you're looking at two servers stacked on top of each other. And what you see here is a grill that's actually lockable for security, so you don't have unauthorized people coming up and flipping the power button or doing something else. Number one, you want to have these servers behind a secure door anyway, but as an additional layer of security, you can snap on these grill covers. If you remove the grill cover, you'll see the traditional trappings of a computer system: an on-off switch, hard drive bays, optical drive bays, etc. They look pretty standard. Nonetheless, this rack server form factor is designed for modularity in business. Let's again take a look at some pictures. Just to pick on Dell for a moment because it's near and dear to me, let's look closer here. You notice that some of these rack servers are thinner than others. In a future nugget, we're going to talk about specifics of the server room in terms of how server racks are built and the size increment that's been standardized upon. It's called the unit. So this guy right here, this PowerEdge 1950, is a 1U or 1 unit high rack server appliance. Depending upon how many hard drives and how much horsepower is involved, the form factor might go up to double size or 2U, as you see in this particular PowerEdge model. You note that Dell also makes tower cases as well, although in my experience the rack-mounted design is much, much better from a space-saving standpoint. In fact, this picture here shows some Dell PowerEdge boxes already installed in a rack. You'll find that with enterprise computing hardware, almost always those appliances fit into a standard server rack, again, for space saving, for modularity, and for security. Now to paraphrase Jerry Seinfeld, what's the deal with portable or laptop computers? First of all, you'll sometimes see laptops referred to as notebook computers. Don't get confused when you see these monikers. They're all essentially the same. Portable computer, laptop computer, and notebook are synonyms for full fidelity PCs that are in a special case, a special form factor to enhance the device's mobility, to give it the lightest weight and smallest profile possible, such that a business user can easily tote his or her laptop on bus trips, train trips, plane trips, and so forth. And third, laptop devices are intended for low or minimal power consumption because the idea is you're mobile with your laptop. You do not always have access to AC power, so battery life is a key purchasing decision that you have when you're selecting a laptop PC. Now, notice that I said that a laptop is a full fidelity PC. I made that distinction when we discussed desktop PCs as well. Full fidelity means you have the entire desktop PC experience, but in a smaller case. That is to say, you have CPU power that rivals that of a desktop computer. You have, in some cases, as much RAM. I mean, my Dell notebook computer has more RAM than my workstation desktop computer has, for instance. Graphics. So you tend with laptops now in the 21st century not to make much of any concession with regard to performance or the user experience. Now that definitely wasn't the case. There used to be a huge disparity between the user experience of a desktop PC and a laptop PC. Now, because we're dealing with a small form factor, you have specialized hardware. In point of fact, you'll sometimes come across PC repair technicians who specialize in laptops. And you may find alternatively computer repair technicians that know nothing of laptop repair, but they're great with desktop repair. The reason for this is, although the basic subsystems in laptops are the same, hard drive, memory, CPU, expansion buses, the way to get to those components is very different in laptops as opposed to PCs. You look in the lower right, you see a stack of what are probably SATA or PATA hard drives, and they're kind of arrayed like a hand of cards. That's because these little 3.5-inch hard drives are notebook-sized hard disks. And it's amazing the capacity that you can fit into one of those small form factor hard drives. Another thing you should be aware of is that memory in laptop computers also has a smaller, more compact form factor. As a matter of fact, the specific type of memory module that's used in almost all laptop computers is the small outline DIMM or SODIMM module. You see, it's the same basic motif in terms of a module plate with connectors and then your actual RAM chips soldered onto that plate. Because we have full fidelity with laptops, we're running full version operating systems. We don't need to run a cut down or scaled back version of Microsoft Windows. If you're purchasing Apple hardware, then those machines will be running Mac OS X. A lot of enthusiasts and power users install different distributions of Linux on their laptop PCs. The list goes on and on. Let's take a look at some pictures of laptop internals. This ought to be pretty instructive. As I mentioned, just getting to the inside of a laptop computer is no easy feat. In my experience, I almost always will want to have the technical manual provided by the original equipment manufacturer, so I know how many screws in the case I have to take out, and specifically how you would remove the keyboard and get down into the guts of the machine. Believe me, these things are so delicate, you want to double check with the OEM before you just start tugging at the case, because one hard tug could wind up permanently breaking the case so that it never goes back the way that it was originally. Because again, the form factor of laptops is so small, you notice that things are very, very cramped in the system. Here we have our hard drive. Because shock absorbency is key with these laptops, it stands to reason that a percentage of customers are going to accidentally drop those laptops. A lot of times the cage that the hard drive is encased in has some rubber bumpers or other shock absorbent mechanisms in it. Nowadays in 2010, 2011, higher-end laptops will have solid-state hard drives that provide even more shock resistance. You'll notice we have in the middle our SO-DIMM RAM chips. This provides some expandability. Some of the better OEMs will actually have just a little door on the bottom of the case such that you can remove the little door to perform a RAM upgrade without having to expose all of the guts of the laptop. This is a laptop that's been pretty much field stripped. It's had the bezel taken off the top to expose the display. Replacing a display is a pretty tedious exercise. I've done it plenty of times. But it can be done if you are a qualified PC or laptop repair technician. Keyboard tends to snap away with a single ribbon cable, and then you see that we've field stripped the RAM modules, the case fan, the hard drive, and then the battery. Staying with our portable computer or notebook computer, laptop computer motif, now let's turn our attention to tablet PCs. Tablet PCs are, again, full-fidelity laptop computers. However, what differentiates a tablet PC from a traditional laptop is the absence of a keyboard. S is medical shorthand terminology for without. I have a lot of folks in my family who are in the medical biz, so it kind of rubbed off. The way you do input on a tablet PC, especially a slate model that has no keyboard at all, is either touch, where you can use finger gesturing, or as you see in the picture here on the right, a stylus pen that mimics the behavior of a mechanical or optical mouse device. Form factors for tablets include, as I said, the slate, which is simply basically a monitor, an all-in-one piece with the monitor and all of the guts together in one unit, kind of like the top panel of what you see in the picture. And only touch or stylus is supported unless, for instance, you were to plug in an external keyboard. Another tablet PC variety is the convertible or hybrid, and that's specifically what you see back here, where at first blush this looks like a regular laptop computer that has a broken monitor. This actually is a swivel where you can convert the monitor, flip it over and snap it down to make this a stylus-based or touch-based slate PC, and then when you need keyboard input you can pop the screen back up. Tablet PCs tend to require specialized software, for instance, handwriting recognition software that can convert your stylus input into printable characters, this kind of thing. Microsoft Windows in particular has done a good job at that sort of translation. Tablet PCs have their role for sure in specialized work environments, maybe warehouse workers, that it's just impractical for them to carry around a full fidelity laptop. They can carry a slate and do input and output just with, as I said, touch or stylus. Tablet PCs have been supplanted somewhat by true slate devices. One that's particularly hot nowadays is the Apple iPad. I haven't read much or heard much of anything with regard to the iPad used in business yet, but I imagine that's coming at some point. iPad is particularly hot in the higher education market and the consumer market. I love my iPad. I use it every single day. To take the form factor down another notch, let's look at personal digital assistants, PDAs, and smartphones. Now, one has essentially become the other. Now, what do I mean by that? A PDA or a smartphone, first let's look at their similarities, are small computers. They're not full fidelity PCs like all of the devices we've looked at thus far. We're going to make some concessions. It's a lot harder, for instance, to print from a PDA than it is from any other device that we've looked at thus far. It can be a challenge, depending upon the device, to hook up a full external keyboard to do keyboard-based data entry on one of these PDAs or smartphone devices. However, what you lack in concession, you gain in convenience and portability, especially now with the current generation PDAs and smartphones on the market. These devices tend to support various input methods, stylus pen, virtual soft keyboard where the keyboard is integrated in the screen and it's touch sensitive, and then using finger gesturing. Connectivity for PDAs and smartphones is given by a variety of technologies: Bluetooth short range, especially for smartphones and cell phones. This can be handy for link up with a vehicle, an ear microphone, headset, etc. Wi-Fi connectivity that can give you a much faster internet browsing experience for sure. And then carrier, Verizon, AT&T, Sprint, whoever it is that's providing your cell phone service, almost always nowadays will offer a data plan as well where you can do email, web browsing, and so forth. And then IR is still around, believe it or not, infrared sensors for the very short range exchange of data between compatible devices. Now, because PDAs and smartphones are small form factor computers that are not full fidelity, these guys run specialized operating systems. And I'm a little bit ashamed of myself that I haven't formally defined operating system for you yet. An operating system is software that fundamentally controls the relationship of system hardware and the user. It serves as a boundary layer between the underlying hardware and then you, the user. Actually, there's one more level between OS and user, and that would be the software applications that the user uses. But you get the general idea. Examples of PDA or smartphone OSs include the Palm Web OS, the Apple iOS, Microsoft's Windows Phone 7, and Google's Android operating system. Each of these has a cadre of very dedicated followers indeed. Historically, PDAs or personal digital assistants were decoupled from smartphones. As a matter of fact, smartphones really represent a convergence of a cellular telephone and a personal digital assistant. Therefore, sometimes you'll call smartphones like the iPhone or the Droid X, etc., convergence devices because they converge the functionality of a phone, of a PDA, and even an internet-enabled computer. Back in the day, that is to say the 90s, the dark ages of this technology, you had dedicated personal digital assistants. In fact, I had this one, the Palm V, or Palm 5. Boy, this was a hotshot device. You notice that there's no color screen. You actually would use a stylus pen that fit in this silo here to do all your input. This writing area down below, this was a stylus input area, and Palm had its own input language called graffiti, where you could just use single stroke symbols to put in one letter at a time, whether it was an appointment or a new contact and so forth. No internet access whatsoever. When you wanted to synchronize the data on your PDA with your computer, you'd pop it into this cradle here, connected originally serial port and then became USB to make that happen. Nowadays, though, in the form of the smartphone, we again have this convergence between the telephone, the computer, and the personal digital assistant. This is a Windows Mobile OS device by Verizon. You'll notice that it slides out to give you a full QWERTY hardware keyboard. Other devices, as you know, like the iPhone, have a soft keyboard where it can take a little bit of getting used to actually because you're typing on the screen on a virtual keyboard instead of with keys. As far as those specialized operating systems I told you about, let me show you a little screenshot from the Google Android operating system. Really, they're all about the same. I know I'm going to make a lot of people angry by saying this, but an operating system is an operating system. The Apple iOS is really neat. My wife and I both have iPhones, so if that says anything. Android has, like I said, a loyal following. Windows Phone 7 has some really promising features. But at base, again, it presents, the OS does, an interface between you, the user, and the underlying hardware. We can click these icons, or I say click, tap these icons to do calculations, to do web browsing, to dial the phone, to do email or text messaging or even instant messaging. Same basic metaphor, different implementation. The final form factor in this nugget that we'll look at is the netbook. Not to be confused with notebooks. In point of fact, netbooks are often referred to as sub-notebooks. Netbooks are very small form factor laptops. You could look at a netbook as a subcategory, hence sub-notebooks, of true laptop computers that have a basic specialized purpose. Generally speaking, you're going to want to purchase a netbook to give you a fairly decent email web experience over Wi-Fi connectivity. You see in the lower right, at first blush, this HP netbook looks like a full fidelity laptop. I mean, it has a QWERTY keyboard, color display, it has a touchpad interface. It looks like we've got USB ports and a VGA out port on the side. I mean, there's quite a bit there. However, I hesitate to call a netbook a full fidelity PC because it's really not. When I say it's not, because the form factor is so small, technology really hasn't caught up to the point where a netbook is going to be anywhere near as fast as even the lowest end laptop computer. The most popular CPU used in netbooks is the Atom processor from Intel, and while it's promising, as I said, as of this recording, netbooks tend to be dog slow. Over our recent vacation, I was playing with my twin sister Trisha's netbook and was really quite appalled not only with the slowness of the device, but also the behavior of its operating system. Netbooks can take Linux. In fact, what can't take Linux? That's a running joke in the IT industry. See if you can get Linux to run on just about any hardware platform in the world. Google Android is on some netbooks, and then we have Windows XP and Windows 7. Now, specifically with Windows 7, you might think, well, that's pretty impressive, a netbook running Windows 7. But in my experience, and this was played out recently with my sister's computer, it had Windows 7 Starter Edition installed. Starter is the smallest, the most stripped down version of Windows 7 that Microsoft offers. And basic functionality that anybody would expect in a computer, such as the ability to personalize the experience by changing the desktop wallpaper, is not present. It just doesn't make sense to me, but that's the way it is. So what do we use netbooks for? As I said, they're used for a special purpose if you want a really, really portable computer experience where you can plug in your external mouse and not have to worry about like a tablet PC where you're touching it all the time. You can go it old school, so to speak, where you'd make some concessions and loss of some functionality that you would have in a laptop, but it would still nonetheless be worth it for you. The precursor to netbooks were these low-cost, dedicated email devices. I don't think these really got very far in the industry. These are small form factor pieces of hardware that have limited carrier-based or potentially Wi-Fi connectivity where you're really literally limited to doing one thing. And this particular device does email, and that's all it does. As you can see, the narrowness of focus there kind of doomed that device from the start when you think about it. Quite a few of these email devices you can find on Google Images. I also wanted to show you a screenshot of the iPad, because this is an example, although it's not officially a netbook, of a soft keyboard, where if you've never seen or worked with these, they can take some getting used to, but definitely saves you some room as far as not having a slide-out keyboard tray or having to plug in a physical external keyboard. Can give you the full QWERTY experience with a little bit of a learning curve thrown in. Device usage review. We began this nugget by looking at computer monitors, chiefly differentiating between the old school CRTs and the current generation LCDs. We looked at those hard buttons on the front of the monitor that we can use to make quick global adjustments, the auto adjust feature, etc. We then spent the lion's share of this nugget looking at the various device form factors, from desktop PC to workstation PC to server to notebook, to netbook, you got it. Soup to nuts. At this point, you should be able to immediately identify by sight the type of device you're dealing with if you happen to be visiting an OEM's website or you're in a showroom and you're physically there with hardware. I hope that this has been informative for you, and I'd like to thank you for viewing.